Okay, so last section we're going to look at this week is 2.1 and part of 2.2. Okay, 2.1 focuses on zeros or roots of polynomial functions. Okay? One thing we want to be able to do is be able to look at an equation quickly and say, all right, that could cross the x-axis at most 3 times. At most. I'm not saying I'm guaranteeing you it'll cross 3 times. It could only cross twice. Could only cross once. That one couldn't cross 0. And it has to do with the fact that this is a polynomial and the highest exponent is odd. I'm not going to get into it right now. But let's see if we can graph it and figure out how many times it crosses. Okay, so let's type it in. So 2x cubed minus 3x squared minus 3x plus 2. Now this may or may not be a good window. I don't know yet. Actually it is. Just a standard window. How many times does it cross the x-axis?
3 times.
3. You get 3 times. What's the y-coordinate of each one of the points where it crosses the x-axis? 0. I don't know what the exact x-coordinate is. I could find it. I could guess what it is. But the y-coordinate is 0. Any questions why the y-coordinate is 0? Where that graph crosses the x-axis?
Why is it 0? The y-coordinate?
So the reason it's 0 is because you haven't gone up or down at all. You're right on the axis. Anytime you're on an axis, one of your x or y values has to be 0. If you were on the y-axis, like say you just went up 3 units, the coordinate would be 0, 3, because you didn't go left and right. Okay. But this one, we're not going up or down at this point, this point, this point, or that point. Don't really need that. 0. All right. So let's distribute all this out and watch what happens. Okay, I'm going to show you something. All right. And it's going to connect with what we just did. So to distribute it, we'll do the first 2 and then do the third one. So x times 2x gives me 2x squared. X times negative 1. And a 2x gives me, so combine them. X. And 1 times negative 1?
Negative 1.
Negative 1. Okay, and we'll do it one more time. So now distribute 2x squared times x. 2x cubed. 2x squared times negative 2.
4x.
Squared. X times x. X times negative 2. And negative 1 times x. And negative 1 times negative 2. Plus 2. Now combine like terms. There's no other cubes except the first one. Negative 4x squared plus x squared. Negative 3x squared. And negative 2x minus x. Plus 2. 2x cubed minus 3x squared minus 3x plus 2. That's exactly what I started with. It's the exact same equation. That one has been FOILed out. The one I gave you right here was factored. Okay. So any questions why they're equivalent? All right. Now taking this and going back to this, factoring cubic, that's a little harder, but it is something we're going to do eventually. So you will, within a month or so, you should be able to take this and go back to the factored form. As long as it factors nicely, right? Which this one does. So let's find all the roots of this equation. Okay. Basically, I've taken this equation, set it equal to 0, and I'm going to do it on the graphing calculator. But then I'm going to come back to the factored form of the equation. Okay, and see if you notice something. Okay, so to calculate a 0, you do second calc 0. And then you have to pick a point that's to the left, pick a point to the right, and do a guess. Okay, I'm going to do the one on the left side. So pick a point that you know is definitely to the left, and it puts on a dotted line. Pick a point that you know is to the right, and now it's going to look between the dotted lines for the root.
Wait, what are we trying to find again?
0.
Oh.
Okay. And on mine it says 0 occurs when x is -1. So that's one of them. If you went through and did it a second time on, you don't need that one, you would get 1/2. That would be the second one. And if you did it a third time, second calculate 0, you would get 2. That would be the third one. Now, you can get all those very easily from the graph. But if you look at the factored form of the equation, does anybody see how these numbers connect to the factored form?
Yes.
How? Yeah.
For example, x plus 1, one with parentheses there, if you plug in -1, it would cause it to equal 0. And if you multiply 0 across the other parentheses, it would in total equal 0.
Yeah. So a factored equation, it's very easy to find roots, because remember, to find roots, all you have to do is make each factor 0. So the first factor could equal 0, solve it. The second factor could come out to 0, or the third factor. If any one of those, if you can find an x value to plug it in and make it 0, you will make the whole thing 0. And you will be finding what's called the roots of the equation. Not so easy to do when it's like this. If you just set that equal to 0, how are you going to solve it if it's not factored? We don't have a cubic formula. Well, there is one, but we don't know it. There's a quadratic formula, so you could get around if it was just no cube term. You could do it. But with that cube term, you've got to do something, like factor it, or if you can't factor it, we'd really be pretty stuck. Unless you could graph it and then do it that way. Okay? So if you solve what would make the first factor 0, you get -1. If you solve for what would make the second factor 0, you get 1/2. What would make the third factor 0? 2. Okay, so that's a strategy we're going to use a lot when we have to find roots. We're going to have to factor it. And that makes it easier to see the roots. Any questions on that? Okay. So, if a number is a solution to the equation f of x equals 0, like, let me just go back and look at the one we had. All right, -1 was a solution. So, if -1 is a solution to the equation f of x equals 0, then that number, comma 0, is the coordinate of the x-intercept. So -1, comma 0 was one of the x-intercepts in that graph. Okay, I think the other one was 1/2 maybe? 1/2, comma 0 would be an x-intercept, and 2, I think it was 2, comma 0 would be an x-intercept. Okay, so if you find a number that you can plug it in for x, and it gives you 0 for y, you just found the x-coordinate of the x-intercept. And the y-coordinate is 0. Any questions on that idea? Okay. So that number that you found, it's called a root. It's also called a 0 of the equation. Most newer calculators, when you go to second calc, it's going to have the option for 0. Okay, an older calculator, it used to say root, but they mean the same thing. So what would be the difference on a test if I said, give me the x-intercept versus give me the zero of the equation? I mean, they're similar, but they're not exactly the same way you would write the answer.
The zero is just the x.
Yes. The zero is just
x-intercept
the x
is
part.
the whole point.
And the x-intercept is the whole coordinate. Yep. All right, so for linear equations, those are probably one of the easiest kind of equations to find the roots. If it's written in the form ax plus b equals 0. So like 3x plus 2 equals 0. There's a quick formula you can use to get the root without even really having to do algebra. How would you get x by itself?
Divide by,
Minus b
and then divide by a.
over a. Yep, so it's just minus b over a, which really is just doing algebra. So negative 2/3 would be the root to this equation. You don't have to remember the formula because you can do it quick enough in your head. Quadratic formula, that one you do need to remember, but this one's not too bad. That's almost the same problem I just gave you. So what would be my root right here? Negative 3/2. How many times can a line cross the x-axis? What are some options?
One.
Could cross once, like this one.
Or 0.
It can't really cross exactly twice. Yep.
Infinite.
It could cross infinite. Yep. What else?
0.
Yep.
0.
0. Yep. So if you had a perfectly horizontal line, that's when you could get 0 or infinite. But you'd never get exactly 2 or exactly 3 unless you have a curve. Lines cross once, infinite, or not at all.
Yeah.
All right. So now let's take it up a step from linear equations. Quadratics. How many roots can a quadratic have? Or how many x-intercepts? How many zeros? Same question. Could have, yeah? Up to 2. What other cases? 2? 1, yeah? Or 0. Yeah, you can have 0 roots with an even degree polynomial, which a parabola is an example of an even degree polynomial, because those generally have a U-shape to them. So if you had a U-shape, it could look just like this. Or you could flip it over and move it down, and it would never cross the x-axis. So 0, 1, 2. Now, we already went over this. How can you use the discriminant to quickly figure out if it crosses 0, 1, or 2 times? The discriminant won't tell you what the exact intercept is, but it will tell you which one of the 3 cases you have. Yeah?
You can solve it, and if it's negative, then it has no x-intercepts. If it has 0, it has 1, and if it's positive, it has 2.
Yep, exactly. So if you do the discriminant, you can go through that. That'll tell you how many times it crosses. All right, so we're going to solve this one approximately. If it says approximate, it means decimals are okay. They're not looking for an exact answer. If they were looking for an exact answer, we would have to do quadratic formula. But we'll hold off on that for a second. So, if I wanted to solve this on the graphing calculator, 2 ways I can do it. One way is to leave it exactly the way it is and put what's on the left in y1, put what's on the right in y2. And what would I be looking for on the screen if I did that? Yeah.
The intersection.
Yep. I'd be looking for the intersection. So let's try it that way. Keep using this one. All right, so let's clear that. 2x squared and 1 minus 2x. Now, I don't know if a standard window is going to be good, but we'll try it and go from there. There's my parabola. That's going to be fine. And how many times does it look like they cross? Twice. And remember, I'm solving for x. Okay, that's what I want to know. So what value of x could you plug in and it would make them equal? All right, so second calc. Second calc. Intersect. And now pick a point on the red, pick a point on the blue, and I'm going to do the one that's on the left. If someone can do the one on the right, we'll get that x value as well. So just move your guess closer to the one you want. So the one on the left is negative 1.37. And the one on the right is another value. Yes?
0.37.
0.37. Okay, and since it's set approximate, decimals are fine. Questions on how you would do that with quadratic formula? What would be the first thing you would have to do if you were doing this with quadratic formula? Set it equal to 0, and this is going to show you another way to do it on the calculator. So I'm going to set it equal to 0, 2x squared plus 2x minus 1. And now, I'm going to type all of that in y1. So let's clear this out. And type in 2x squared plus 2x minus 1. And do zoom 6. Now it's going to cross twice. We already know that because we got two answers. I'm looking for where this graph equals 0 now. So I wouldn't do intersect. If I was doing it this way, which option would I pick here? 0. Okay. I'm just going to do the one on the left. Okay. Pick a point to the left, pick a point to the right, and do your guess. Negative 1.37. It's exactly what I got the first time. If you do the one on the right, it's going to be 0.37. Okay, so same two answers again. Right, so I just showed you two ways to do exactly the same thing. Any question doing it either way? One way takes an intersection approach, the other way looks at the roots. All right, so this part, you don't have to write this down. Just watch this part. Older calculators didn't have second calc on them. So the only way to find a root graphically was basically to do something like this. Right? Press zoom, press 2, and move your cursor over, and hit enter. So I can tell you with complete certainty that there is a root between 0 and 1 because I know my tick marks, my scale, there's a tick mark every 1 unit. Any question on that? All right, so now what I'm going to do is I'm going to change the scale to 0.25 and hit graph. All right, so now I can definitely tell you that there is a root between 0.25 and 5. All right, we know it's 0.37, but I can tell you it's between 0.25 and 5. And now what I would do is I would zoom in again and make my tick marks even closer. Right, so I do like zoom 2, and this really gets to be a pain. It takes forever. Okay, so now I'm zooming in even more. And let's put tick marks instead of every quarter unit. Let's bring it down to every 1/10 of a unit. All right, So now I can tell you that the answer is between 0.3 and 0.4. So I'm getting a more and more accurate answer. And that's the old way they had to do it. Till they got as much accuracy as they wanted. Yeah, it takes a while. All right? So you don't have to zoom in and do that anymore. We've got second calc, and it automatically does it for you. All right? So we don't have to worry about that. So better method is to use second calc. On my calculator, it's called 0. If you have a Casio or an older graphing calculator, it might be called root. Okay, but that's the best feature. That's what you want to use. Okay, let's try this one. Now, this one, it says solve approximately. Well, I'm glad it doesn't say exact because I'm not sure how I would do it exact. It's a cubic, so I can't use the quadratic formula. If it was equal to 0, then that would be very easy to do. But it's equal to 1. So there really is, I don't know how to get the exact answer from that problem. So we're going to just do approximate. Can somebody give me one approach I could do? Answer. Yeah.
Equal it to 0.
Okay, we could get it equal to 0. So we could do x cubed plus 2x minus 1 equals 0. And now what would be my next step, Armin?
After that, you graph it to the y. You graph it x cubed plus 2x minus 1.
Okay, so I got that typed in. And what would be my last step?
After that, you do second calc. And then find 0.
Yep. So he chose to get it equal to 0. Some of you might have said, I'm going to put what's on the left in y1, what's on the right in y2, and do an intersect. That would have worked as well. Pick a point to the left. Pick a point to the right. And do your guess. So you should have gotten about 0.45. Okay. All right. Any questions on that? All right, so not bad. So, third degree polynomials. So now we're taking it up another step from quadratics. Third degree polynomials have that form. A, B, C, and D. Those are all your coefficients. Except for D, that's a constant. But A, B, and C are your coefficients. They can be any real numbers that you want, except A can't be 0. Why can't A be 0? Yep.
Because that would make that entire term equal 0, and then it would just be quadratic.
Yeah, exactly. We'll wipe that right out, now you have a quadratic. So, page 80, but I also draw them here, shows some different types of third degree polynomials. Couple things to remember about third degree polynomials. They can turn twice. Okay? The number of turns a polynomial can take is 1 less than the highest exponent. Right? So this counts as 2 turns. 1, 2. The other thing about odd degree polynomials in general is one end always goes down forever, the other end always goes up forever. So that makes the range of every single odd degree polynomial negative infinity to infinity. Every one of them. Even polynomials, no. Even polynomials like a parabola, they may have a minimum value, or if you flip it over, the parabola could have a maximum. But that's how odd degree polynomials generally look. So if it can turn up to twice, how many times could it cross the x-axis? Up to 3. If you put a line in like this, and you had one of these examples on the right, it could cross 3. Could cross 2 if you had it like that. If that was the case for the one on the right, where it comes down, it touches it, and then bounces away from it, when you factor it, something special would happen. Okay? We don't have to worry about it right now, but you would know that that would happen once you factor it. Okay? And it could cross once if it was like that. But you'll never get 0. No matter where you put that horizontal line, it's going to hit that graph somewhere. And if you want, you can look it up. There is a formula for solving cubic polynomials, just like we have for quadratics. But the difficulty of using it goes way up. I think the formula, it's like a page long. It's like really, really long. And then there's a formula, I think, for quartics, which is 4th degree, but that's multi-pages. Very simple for a computer if you program it, but for someone to do by hand, probably not the best thing. You can look it up, cubic formula. It's not really hard, it's just a ton of steps. All right, so this question, it's just asking how many solutions does the equation have, not what they are. So how many could it have at most? 2. Could, wait a minute, no, I lied, it is 3. I'm sorry. Yes, it could have 3. You could only cross the x-axis 1, 2, yeah, 3 times. How many turns can it take? 2. That's, yeah. All right, so x cubed minus 5x squared plus 6x minus 1. Zoom 6 seems to be working fine for most of these. That might not always be the case. I don't think there's really anything tricky. You don't have to zoom in to see anything hidden. How many solutions do you have? 3. Yep. Is there any question on how you would find, if they said find the one in the middle, how to do it?
You just do the 0 thing?
Yep, you just do the second calc 0. We've done it a couple of times. So I'll skip that. But the middle one would be that one right there. Great. So let's look at the last part of lesson for today. 2.2, part 1. So remember, when you find a complete graph, that's not something you really do on paper. It's something you do on the calculator, and you write down the x-min, x-max, y-min, y-max on paper. So when we solve word problems, usually when you're solving a word problem, part of it involves making an equation. Okay? And that equation, we call it the algebraic representation of our problem. Okay, that equation kind of takes out the fact that, maybe the word problem is about somebody renting a car and they drove it 30 miles and all this stuff. Well, when you write an equation, you're taking out all that stuff and you're looking at just a pure math, okay, out of context from the word problem. Okay, I think we've already said that before. But let's say Bill invests $20,000 and he has 2 investments to pick from. He's going to put some of his money in an investment that pays 6 3/4%. And he's going to put the other amount that he has left over in an investment that pays 8.6%. And the type of investment we're looking at is, it's called simple interest. Not quite the kind of interest that your bank would pay. They use what's called compound interest. But that formula, it's a little more complicated, so we're going to stick with what's called simple interest for this problem. But it's basically like he's putting money in a savings account. Right. So 2 investments to pick from. So you might say, why wouldn't you just pick the investment that pays more? Well, maybe the investment where you have a chance of earning more money is riskier in real life. So you can earn more money, but you could also lose money. So like I have stocks and different things, and you can't really look at it every day because it may change thousands of dollars a day. So I may lose $2,000 in one day and go, oh my God, I just lost $2,000. But then I may make $3,000 the next day, right? So I honestly haven't looked at my stocks in probably like 6 months. I don't know. I don't really care at this point because I don't plan on touching the money till I'm much older. So it doesn't really matter what it's worth right now. It matters what it's worth like in 25 or 30 years. That's when I kind of care. So that's why when people get older, they usually take their money out of something that's risky, put it in something more conservative. Because as they get older, they don't have as much time if something goes wrong with the stock market. If something goes wrong, then they might lose all their money, and they don't have enough time before they retire to make it back.
But you probably want to check the long-term trend though.
Yeah, yeah, you
If
can
your
look
stock
at it.
was like
Yeah.
over the years just going like this, when you probably want to take your money out of that stock.
Yeah, if you look at like trends and you see something's always going down, you might
Like
want to
the
switch it.
5-year trend.
Yeah. Yep. So you can look at all. There's so much with stocks. If you're ever interested in investing, I do a lot with that. So you could always talk to me. But it's pretty neat. Invest in like gold. You can invest in stocks. You can do all kinds of stuff. So the formula that you would need for this problem is the simple interest formula, because it's a pretty simple formula. I equals PRT. So it has 4 variables. I is the interest that you make. P is called principal. That's the amount of money that you invest. R is the rate that the investment is making, but the rate always has to be as a decimal, not a percent. And T is time. So I want to find an equation, an algebraic representation of the interest that Bill is going to earn in 1 year. And to give you a hint, I mean, you've got to start off with something. Let's just assume that he invests X dollars at 6.75%. We don't know how much, but we'll say he puts X. Now, you could have said, assume he invests X dollars at 8.6%. It doesn't really matter. It just would control which thing you're solving for. But since we know he invested a total of $20,000, it's not that hard. Once you know how much money he invested in one, just the difference is what he invested in the other. Okay. All right, so let's see if we can figure out the interest. So he's doing 2 investments. Let's start out with the interest he would make in the 6.75% investment. Right, so I equals PRT. How much money is Bill investing at 6.75%?
X.
X. What's the rate of that investment?
6.75.
No.
0.0675.
Yes, 0.0675. And what's the amount of time that they want us to find the interest for? 1 year. So we don't really need that. Right. So what it comes out to is 0.0675x. That's a formula for how much interest he would make in 1 year at 6.75%. Any questions on that? Okay. Let's figure out how much interest he would make at 8.6%. How much money does Bill invest at 8.6%? $20,000 minus X, yes. So he's already invested X. That's what he has left. And what's the rate of this investment?
0.086.
Yes, 0.086 or just 0.086 is fine. And the time again? It's for 1 year. This one, which property would I have to use to simplify this? Yep. So let's distribute it out, and I'm going to write it in like mx plus b form. So negative 0.086x plus 20,000 times 0.086 times 0.086.
It's above the 9.
Thank you. So it's 1,720. So that's how much interest he makes at that one. Now, they said find a formula for the interest earned in 1 year, which is both investments. So what would I do with both of these boxes?
Add them together.
Add them together. So we've got 0.0675x. So we'll just say total interest equals 0.0675 plus, well, it's plus negative 0.086x. So really, it's going to end up subtracting those two. All right, so let's see what we got. 0.0675 minus 0.086. Negative 0.0185x. Plus 1720. So that's a formula for his total interest that he makes. Any question on the formula? All right, then I think the next part, they're going to have us use that formula to do something. Yes. All right, so we're going to graph this in a minute. But what's the difference between just graphing this equation we came up with, like just the way it is, out of the context from the word problem, and then graphing it in the context of the word problem? Thinking about like your x min, your x max, your y min, your y max. Like what would be the difference between those two graphs? Yep.
When you're kind of like in the real world, there are different restrictions set on different things.
Yep.
Like quadratic tags.
Yep. And what would be a restriction in this problem if you were graphing it in the context of like the word problem, the real world?
I wouldn't.
Yep.
You can't have negative time.
You can't have negative time, right? So negative time wouldn't really make sense. What else about these variables? Like x is an amount of money. It's actually two restrictions on the amount of money. Yep.
You can't invest a negative amount of money.
You can't invest a negative amount. And what else can't you invest? I guess technically you could plug in 0 and it would just mean you invested no money in one investment and all in the other. So that 0 is okay. But there's something else you can't do here. Yeah?
Fractions of money?
Fractions are okay as long as it's to the 100th. You couldn't invest like thousands of them because you can't. Money isn't divided down that small.
Invest them to the center.
But you can invest down to the nearest cent.
Why though?
Yeah.
We do that like all invest quarter guys.
So negative rate,
Ton of cash.
that would be part of the word problem itself, and they wouldn't give you that. But yeah, you couldn't have a negative rate. That wouldn't make sense unless you're losing money. But this isn't about losing money.
You can't invest infinite money.
You can't invest an infinite amount of money. How much can you invest?
I remember.
20,000.
20,000 in this problem. So when I go to graph this, I'm not going to set my amount of money to more than 20,000 because I can't go more than that. All right, so 0 to 20,000 would be good. Right, so we'll graph it right now. So let's say that Bill invested in each investment and he ended up earning $1,509.10. How much did he put in the lower investment, the 6.75, and the higher investment? How much money in each? Okay, so let's graph it. Okay, so I'll need someone just to remind me of the what was the equation we came up with?
Negative 0.0185x plus 1,720.
All right, thank you. So let's think about this a little bit. So 1720, that's like a y-intercept. So I definitely want my y-max, maybe 1800. Okay. Could I lose? Is this a problem about, is there a risk of losing money here?
No.
No, it's a simple interest problem, which I said is kind of like a savings account. You never lose money in a savings account. It's not like a stock market where you could check it the next day and all your money's gone. Right? Shouldn't happen. So, not going to have negative money. Could we have, let's see, or negative interest. Could we have negative investment? X is how much money we invested at, I think, 6.75. Can't be negative. And what's the most amount of money we have to invest? 20,000. So let's graph it. So you look at it and it's going down. Why is it going down?
We have a negative rate.
Both our rates are positive. One's 6.75 and one's 8.6. I know we have a negative slope in the formula. But can anyone else explain to me, like, in terms of the word problem, why the slope is negative? Well, which axis is this on the bottom? So as x gets bigger, the amount of interest goes down. Why? Well, what's x? Nope, it's not time. We said something.
It's how much money you put in
Where?
into the investment.
Which one?
The
The six. Nope, it's not both of them. We said x is the amount of money in the 6.75. Assume x dollars is invested at 6.75%. Is that the lower investment or the higher one? The lower one. So when you look at your graph, x represents putting, as you head to the right, that represents putting more and more money in the investment that pays less. So the more money you put in the lower investment, the lower your total interest is going to be. Your best option would be to just put all the money in the higher interest rate. But again, in real life, maybe that would be a risk because you could lose money. But that's why it's slanted down. All right, so I've got my equation. What else do I need? Somehow I got to use that $1,509. What do I do with that? Yeah?
We could do a graph line that's y equals 1509.1 and then
Yeah.
find the intercept.
Yeah, exactly. That 1509.1, that's the total interest. So basically, I'm just taking this equation right here, and I'm plugging in $1,509.10 in that box. And I'm solving for where they're equal to each other. I could either do that algebraically, subtract 1720 and divide by negative 0.0185, or just find the intersect. And this said use the calculator, so let's do it that way. So it was $1,509. No, I didn't want to do that. Negative point, what was it again?
Negative 0.0185.
18, thank you. And this was $1,509 and how many cents?
1.
10. Okay, 10 cents. Okay, let's hit graph. And let's see where that goes. So second calc, intersect. Blue, red, yes. Yes. So 11,400 is what x equals. Put that. It's kind of weird that it makes it like a shadow like that. Okay, let's just keep going. So, our intersection was, I was hoping to have it on the screen, but it's 11,400. And that was, what's the x again? That's at the 6.75%. What's the amount of money, how would you figure out the amount of money at the 8.6%?
Could you subtract that from 20,000?
Yeah, just take 20,000 and minus 11,400. So he has $8,600 in the other investment. Any question on that? So I equals PRT, that's your interest formula. If you needed that, I would give that to you on a test. And the last one, I think we've done a couple like this before. Actually, we did this exact homework problem. What was the shape? Does anyone remember that gave you the biggest area?
Square.
Yeah, it was a square. So we're not going to go through and graph that again because we did that exact problem. Okay, so first part of the homework, page 82. The second part is on page 88. Don't forget we've got our first test tomorrow. What you can use on the test is your graphing calculator. If you have your own, that's fine. Or if you want to use one of mine, that's fine too. Other than that, that's it. Just your graphing calculator for something you can bring in. Pen or pencil, you don't obviously that. If you do have any questions, we've got about 7 or 8 minutes, and I will be here after school for a little bit.